You're listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and this is the show where you get expert advice about the heavy duty parts you buy and sell and keep you informed about what's happening in the industry. Hydraulic fluid is used in many applications, from Class 8 on-highway trucks and trailers to industrial equipment, things like construction, mining, forestry, agricultural equipment, and much more. Contamination is one of the leading causes to premature failures, and that is the problem that we're really going to try to tackle in this episode. I'd like to introduce you to Bob Eyrig, Applications Engineer for Filter Systems, and Timothy Rodman, Marketing Supervisor from Schroeder Industries. Bob, welcome to the show.
Thank you for having me, Jamie.
Timothy, welcome to the show.
Yeah, likewise. Thanks for having us.
So I'd like to get started by asking you a question, Bob. What is the main problem that Schroeder Industries products really solves for fleets and for industrial applications? What's the economic impact of that problem?
So Schroeder cares about and provides solutions for a variety of problems faced by heavy-duty fleet owners pertaining to the fluid condition of onboard hydraulic fluid power systems. But the main fluid condition problem Schroeder products solve through industry-leading filtration and fluid condition monitoring technologies is solid particle contamination, which is currently found to be a large proportion of unexpected hydraulic system failures, and typically cited to range between 70 to 85% of those system failures. So, as you can imagine, depending on the asset, the associated costs of failure can be significant.
Absolutely. Downtime is the most expensive part of any catastrophic or unscheduled, down repair situation. When we talk about a fleet, you think of someone like, let's say they work in construction and they have a bunch of concrete trucks. If you have a truck that's supposed to be at a job site to get that job done and it breaks down because of this kind of contamination, it's not just the few hundred or a couple $1,000s in repairs, right? There's all those associated costs that come with it.
Oh, absolutely. Absolutely. There are many different types and types of contamination and things that can certainly go wrong. But when we're talking about component replacement costs and root cause of those component failures and those associated costs, particle contamination seems to be the number one, or I guess the most impactful and serious of contamination issues. And it really causes a domino effect to not only the single component, but the entire system componentry as a whole.
Timothy, what are the common reasons for hydraulic systems to become contaminated? If contamination is the big problem, why does it happen?
Yeah, so we touch on at Schroeder Industries a lot of ways that hydraulic systems can become contaminated. In our experience, we've noticed about 3 common issues. Number one is what we call built-in. So when you take a part that was manufactured in a plant that might not meet your clean standards, it might not be as clean as like your home or how you'd like it. When we all think of plants, we think of kind of a dusty, dirty facility. Well, that contaminant, that dirt, isn't just something that your mom and dad come home with attached to their uniform. That's also going into the product of that plant. So when somebody orders a cylinder or a pump or something and that manufacturer isn't taking precautions at their plant, you run the risk of whatever contaminant that's floating in the air or the ground or whatever at their facility, that's going to go into the cylinder, into the pump that you're putting onto your equipment. So oftentimes our end users are introduced to contaminant from the moment that they sign for that new part. Another one that we talk about is dirt ingression. That's when you're operating your heavy machinery in a less than ideal situation, because let's face it, when you're working on heavy duty equipment, you're not in a clean room. You're out in a mining site, you're out in a construction site, dust is flying, dirt's flying. You want to make sure everywhere that your hydraulic connections are sealed, that they are in fact that sealed. because when you're exacerbating the dirt, once that enters into, a loose, uh, like a like a breather fitting or a loose seal connection, if that is loose, then you're sucking in air and you're sucking in all that contaminant, and it's going to enter into your system. And the third one that I like is internal, where you have two or more components kind of grinding up on each other when you're operating. That's going to cause like metallic and like steel components to chip off inside your system and get into the hydraulic fluid.
That makes a lot of sense to me. In the years that I worked in a remanufacturing facility, it was basically the first 10 years of my career in heavy duty. I had to do warranty inspections and handle warranty reports. And every time it was related to something hydraulic, when we would get the report back from the manufacturer, not every time, but the vast majority of times, contamination played a major role in the premature failure of that product. So, Bob, I'm kind of curious, what are the best ways to prevent contamination?
So preventing contamination really begins with understanding and mitigation of the possible sources, as Tim previously mentioned. But it's very unlikely that contamination can be completely or even mostly prevented. It's just a nature of what it is. And when we're talking about particle contamination, we're we're not talking about rocks. We're talking about particles that aren't able to be seen with the human eye. So this is why effective filtration and fluid condition monitoring, either online monitoring or through lab analysis, is vitally important to long-term asset reliability. Fluid condition monitoring helps fleet asset managers identify and quantify the condition, whereas an effective filtration regime can help achieve the required fluid cleanliness.
Okay, so I just wanted to make sure I got that right. You said that the contamination isn't necessarily, or in a lot of cases, it's not going to be visible to the eye. I mean, that explains why people, when they send these in and then they get that report back and say, oh well, that seal failed because of contamination, warranty denied, that's why they're so upset, because they're thinking big chunks of mud that got ingested in the system through something that they did wrong, and they're saying that never happened.
Oh, absolutely. And you could take a quote unquote clean sample of fluid, or I'm sorry, let's reverse that, a very contaminated sample of fluid, hold it up to the light, and you would never see those particles. In most cases, of course, there are those other certain times where it is very visible, especially whenever you're dealing with contamination such as water, and so on, burnt fluid, and so on and so forth. But in terms of particle contamination, what we really focus on in our business model is centered around is helping customers identify, quantify, and take care of or condition their fluids to mitigate these microscopic particles that can't be seen.
You're listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin. We've been speaking with Bob and Timothy, who are from Schroeder Industries, and we've been talking about contamination with hydraulic systems. Timothy, it's not just hydraulic fluid, though, that's susceptible to contamination. What other solutions do you provide from your company?
Yeah, so at Schroeder Industries, we speak to a wide range of applications. To your point, yes, everything that Bob and myself have mentioned prior to this doesn't just affect hydraulic fluid. Contamination affects everything and anything, quote unquote, fluid. So, in addition to hydraulic fluids, our solutions provide conditioning and monitoring options for anything low viscosity, lubrication fluids, process and ballast waters, and diesel fuels and gas. So, like I said, anything that flows, anything that's fluid, everything we talked about, where the ingression, the built-in, can affect it.
Okay, that makes a lot of sense to me. Bob, can you share a success story that kind of illustrates how a customer who maybe used some best practices for their application and they were able to turn things around? I'd love to hear a story like that.
Yeah, so an application that particularly comes to mind is how we were able to deploy 2 Schroeder asset management filtration station units, what we call an AMFS, which is an intelligent offline filtration and condition monitoring product on a mobile cart. We were able to successfully deploy those to improve the reliability of a 100-unit refuse truck fleet, which contamination control is already a huge issue. Or prior to this use case or user case, the manager of this fleet already knew and had already taken steps to mitigate and control contamination. But because of the nature of the operation, cylinders being exposed to the environment, we're dealing with refuse. So there's obviously a heightened exposure to potential ingression points and the ingression of harmful contaminants, as well as other sensitive components. The cylinders, as well as other sensitive components, were being found failing due to particular contamination, premature failure due to contamination. But for the sake of this podcast, let's just say the average particle contamination was measured to be 2 classes higher than what it should be, which is significant. And for the case, for each class, quote unquote, it could mean the difference between a factor of remaining useful life. So, for example, we mentioned that the fluid of this fleet, on average, was 2 classes higher than what it should be. So that was effectively reducing the remaining useful life by a factor of 2. Or if we improved by 2 classes, we can potentially increase that remaining or extend that remaining useful life by a factor of 2. But to achieve the required fluid cleanliness, the fluid was simply being replaced by this company. It wasn't, they had onboard filtration and they had taken certain steps to mitigate and control the contamination, but whenever it came down to costs, it was simply cheaper to replace the fluid to ensure cleanliness, to try to offset those pump and cylinder and other component replacement costs. So that is pretty alarming, because that fluid can be saved with an effective fluid conditioning regime. And this, by replacing the fluid at such a frequency every 6 months on average for this fleet of 100, was costing the customer nearly $98,000 annually. By effectively deploying our AMFS solution, we were able to increase the customer's fluid change duration or frequency to 18 months. So we were able to extend that fluid life by about a factor of 1.5, ultimately resulting in an estimated fluid cost savings of about $65,000. So at the end of the day, the customer reduced the fluid replacement volume and their cost by 66%, equating to a significant cost savings, as well as increase the availability and reliability of the assets, and positively impacted the customer's bottom line at the end of the day.
Right, and that calculation doesn't even really account for the downtime. That was just the straight savings on fluid. So the unexpected downtime, the labor, the lost revenue that would associate with premature failure before. So we're talking about a massive economic impact on, especially, a fleet of 100. It's a good size, but it's not a huge fleet. So that is a huge dollar amount for a company of that size.
Oh, absolutely. Yeah, you're exactly right. So this just touches on pure material costs, but that's not even all the materials saved here in the component cost savings here, the labor. You're exactly right, Jamie.
So, Timothy, what does Schroeder Industries do to educate their customers about the impact of contamination on their hydraulic systems?
Yeah, so we really like to think of ourselves, hopefully, as emerging into the educational space. I know in the almost 5 years I've been here, we've really tried to push our literature and marketing more from a product focused standpoint. So explaining the issues, explaining the problems. The more end users can educate themselves on the harmful effects of contamination to their system, the more in tune they can become with their heavy machinery. Schroeder, we have a very intuitive YouTube channel where we not only promote our products, but also educate, like I said, on the problems that we want people to become aware of. And whether you use our solutions or a competitive solution, we just need to work on cleaning the fluid and cleaning the production and the act altogether. We do, like I said, we're working on our literature that's available to everyone. We have a mobile specific pocket guide as well as a product specific pocket guide, which we really think is almost a storybook way of learning what types of contamination are harmful, what they do to the system, how you can notice if you are having that problem, and what can rectify that situation.
So this education effort isn't just for the owner or the fleet maintenance manager. It's got to include everybody. You want to make that information available, right? Drivers, the people doing the repairs, the repair technicians, everybody has to be involved in solving this problem.
Right. Communication is key because oftentimes the fleet owner isn't going to know that you were noticing some kind of jerky steering one day versus the last day. It's going to really rely heavily on the information that operator. You're absolutely right. In a nutshell, it's very, very smart and intuitive for us to speak to every facet of the operation.
Hey, Bob, can you add something to that?
Yeah, you know what? I apologize. I just wanted to add on to something that Tim said about the operator, and in a lot of cases, the machine performance will reduce by upwards of 20% before an operator would even be able to notice any performance-based issues or possible contamination-based issues, or have any kind of alarming state to even go by beginning to look at possible causes. Or so I think more or less it is a team effort. There are many hands involved in taking control and having an effective mitigation approach towards controlling contamination.
You've been listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and we've been speaking with Bob Eyrig, Applications Engineer for the Filter Systems Department, and Timothy Rodman, Marketing Supervisor from Schroeder Industries. To learn more, go to schroederindustries.com. Links are in the show notes. Bob, Timothy, thank you so much for being on the Heavy Duty Parts Report.
Thank you, Jamie. It was a pleasure.
Yeah, absolutely. Thanks, Jamie.
Thank you so much for tuning in to this week's episode of the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and I just like to remind everyone to focus on cost per mile and let's keep those trucks and trailers rolling. You can watch our next video. Make sure to click the like button, write a comment, and don't forget to subscribe.